NASA's most recent announcement regarding a brand new image from the James Webb Space Telescope has sent shockwaves through the scientific community and beyond. This image, which NASA had kept unusually secretive until now, is said to fundamentally change our understanding of the universe. The significance and impact of this discovery cannot be overstated. It has not only captivated astronomers and scientists but also ignited the imaginations of people worldwide. The repercussions of this finding are numerous, potentially redefining our knowledge of space-time and the very fabric of reality. Since its launch, the JWST has delivered a series of breathtaking images and data, revealing cosmic wonders with remarkable clarity and detail. Each image has offered new insight into the formation of stars, the structure of galaxies, and the nature of exoplanets. However, the recent image that NASA has finally made public seems to surpass these already monumental achievements. The image has been described as both beautiful and frightening, a glimpse into the future that challenges everything we believed about the universe. This particular image depicts a region of space that appears to have a vast, dark void, broken up by what seem to be faint structures. At first glance, one might mistake it for a typical image of a distant nebula or galaxy cluster. However, upon closer examination, scientists have realized that what we are observing defies conventional knowledge. The structures within the image do not resemble any known cosmic formations. They are neither galaxies, nebulae, nor star clusters. Instead, they appear to be something entirely new, possibly a phenomenon that has never been observed before. What makes this image so unsettling is the sheer scale of the void it depicts, vast beyond comprehension, stretching across billions of light-years. The faint structures within it are barely detectable, yet they seem to exhibit a strange and inexplicable order, as if governed by an unknown force. The darkness of the void is more than just the absence of light. It could signify something potentially far more significant, perhaps indicative of a fundamental flaw in our comprehension of the universe's structure. The implications of this discovery are staggering. If these structures are indeed something entirely new, it could mean that our current cosmological models are either incomplete or fundamentally flawed. For decades, astronomers have relied on the standard model of cosmology, which describes the universe as a vast, expanding entity composed of dark matter, dark energy, and ordinary matter. This model has been remarkably successful in explaining a wide range of cosmic phenomena, from the universe's large-scale structures to the cosmic microwave background radiation left over from the Big Bang. However, the new image from the JWST suggests that there may be more to the universe than we currently understand. The presence of these mysterious structures in such an expansive, empty region of space raises questions about the nature of dark matter and dark energy, forces thought to govern the universe's expansion. Is it possible that these structures are remnants of an earlier cosmic epoch, or perhaps represent a new phase of the universe's evolution, one that we have yet to comprehend? One of the most intriguing aspects of this discovery is the potential connection between the structures in the image and the concept of dark matter halos. Dark matter, which comprises approximately 85% of the universe's mass, is invisible and interacts with ordinary matter only through gravity. It is believed to create halos around galaxies, holding them together and influencing their movement. Yet the structures in the JWST's image do not conform to the typical profile of dark matter halos. They are far more diffuse and irregular, suggesting they may represent a new type of dark matter structure, or even a completely different form of matter altogether. This discovery has profound implications for our understanding of the universe's expansion. According to the standard model of cosmology, the universe has been expanding since the Big Bang, with the rate of expansion accelerating due to dark energy. However, the new image raises the possibility that the universe's expansion may not be as uniform as previously thought. The existence of such enormous empty spaces with faint structures suggests that these could be regions of space where the expansion behaves differently, or where unknown forces are at play. This could lead to a revision of our understanding of the universe's overall structure and evolution. Moreover, the discovery of these mysterious structures also impacts the search for extraterrestrial life. For decades, scientists have speculated that life might exist elsewhere in the universe, possibly in regions with conditions similar to those on Earth. However, the new image challenges this assumption, indicating that there might be parts of the universe that are fundamentally different from our own. If these structures are indeed composed of an unknown form of matter, they could potentially harbor forms of life completely unlike anything we have ever imagined. Another intriguing possibility is that the structures in the image are connected to the idea of cosmic strings. These theoretical objects are thought to be the remnants of the early universe and are characterized as narrow, one-dimensional defects in the fabric of spacetime. Cosmic strings are believed to be incredibly dense and powerful. If the structures in the image from the JWST are indeed cosmic strings, it would provide the first direct evidence of their existence and could help explain some of the most puzzling aspects of the universe's structure. The implications of this discovery extend beyond the realm of science. The picture taken by the James Webb Space Telescope has the potential to change how we perceive our place in the universe. For centuries, humans have gazed at the stars and pondered the nature of the cosmos. This new image challenges our comprehension of the universe and our place within it, compelling us to confront the possibility that we may not fully grasp the true nature of reality. As scientists continue to analyze the data from the JWST, they are likely to uncover more about these mysterious structures. However, it is also possible that this discovery will generate more questions than answers. The universe is a vast, complex, and diverse entity, and each new finding only deepens the enigma. The image captured by the JWST serves as a reminder that there is still much we do not know about the cosmos, and that the universe is far stranger and more wondrous than we can imagine. The impact of this discovery on the field of astronomy cannot be overstated. Astronomers have, for decades, relied on a set of well-established theories and models to explain the behavior of the universe. But the brand new image from the JWST suggests that these theories may need to be revised, or even replaced. This prospect may be daunting for scientists, but it is also exhilarating. Discovering something entirely new in the cosmos is a rare and important event, one that could pave the way to a new era in scientific exploration and discovery. However, the recent image captured by the James Webb Space Telescope introduces an element of uncertainty into this framework. It suggests that the cosmic narrative we've constructed might be missing key chapters, or perhaps entire volumes. The presence of these anomalous structures in the vast void challenges the completeness of our cosmic map and invites the possibility that unseen dimensions or forces may be shaping the universe in ways we have yet to fathom. Some theorists are already proposing bold new interpretations. Among them is the idea that these structures could be evidence of a multiverse, parallel universes that exist alongside our own, separated by boundaries we do not yet understand. If this were true, it would mean that our universe is only one of many, and that these voids and formations may represent points of contact, interference, or divergence between these realities. While speculative, the multiverse theory has gained traction in recent years as physicists search for a unified theory that can reconcile quantum mechanics with general relativity. Another theory gaining attention suggests that these structures may be related to primordial black holes, hypothetical black holes formed in the earliest moments after the Big Bang. These ancient entities, unlike typical black holes formed from dying stars, could be responsible for seeding the universe with matter or even shaping the large-scale structure of the cosmos. If the formations in the JWST image are influenced by such entities, it would offer unprecedented insight into the hidden scaffolding of the universe. As data pours in and research deepens, the international scientific community is mobilizing. Teams across the globe are using supercomputers to model the observed phenomena and cross-reference the data with results from other observatories, including Hubble, the Chandra X-ray Observatory, and radio telescopes like ALMA. The goal is to triangulate the nature of these structures using different wavelengths and methods of observation. If the findings are consistent, it will lend further weight to the hypothesis that something truly new has been uncovered. Meanwhile, the philosophical and existential implications are also being considered. The idea that there are parts of the universe so fundamentally different from our own corner of reality, so unfamiliar and immense that they appear almost empty or alien, can provoke a sense of awe, but also unease. It forces us to ask profound questions. Are we alone in a universe where other forms of reality might exist? Are we truly capable of comprehending a cosmos that may operate on principles beyond our understanding? In educational institutions, science communicators and professors are already adapting their materials to incorporate these developments. For students and the general public, this discovery is more than a distant scientific curiosity. It is a moment to reawaken interest in cosmology, physics, and the enduring human quest to understand where we come from and what lies beyond. The James Webb Space Telescope, in this regard, is fulfilling its most ambitious purpose, not just to observe, but to transform. By peering deeper into space than ever before, it is not only allowing us to see the past, it is forcing us to confront the future. A future where new physics may emerge, where the boundaries of the known universe stretch even further than we imagined, and where every answer brings with it new mysteries. As we await further analysis and potential peer-reviewed studies on the implications of this image, one thing is certain: we are standing at the threshold of a new cosmic era. Whether it confirms our boldest theories or shatters them entirely, this discovery from the James Webb Space Telescope marks a pivotal chapter in humanity's ongoing dialogue with the stars. JWST introduces elements that do not neatly fit within this framework, prompting scientists to rethink some of the most fundamental concepts in cosmology. One of the most striking features of this image is the presence of a vast void that is both larger and more perplexing than any cosmic void previously observed. Cosmic voids are defined as vast regions in space that contain significantly fewer galaxies than the cosmic average. These voids are not entirely empty, they are sparse, with few galaxies and a lower density of matter, often surrounded by dense regions filled with galaxies and clusters. This forms a structure like a web across the universe, known as the cosmic web. However, the void revealed by the JWST is different. It's not only a region of lower density but appears almost completely devoid of all matter in its current form. The scale of this void is staggering, stretching across distances that are difficult to fathom. The faint, ghostly structures that fill this void add to its enigma. These structures do not correspond to any known type of galaxy or star formation, and they appear to follow a directive that goes against the randomness typically associated with such voids. The discovery of such a vast, empty region challenges existing models of cosmic structure formation, pushing scientists to re-evaluate their understanding of the universe's composition and evolution. As astronomers delve deeper into the implications of this image, it may lead to groundbreaking advancements in our understanding of the cosmos and our place within it. According to current theories, galaxies and matter should be relatively evenly distributed throughout the universe, with occasional variations that result in voids and clusters. However, the sheer scale and emptiness of this void captured by the JWST suggests that there may be processes at work that we do not yet fully comprehend. This observation implies that our models of the universe's formation and evolution could be incomplete, or may require significant revision. One possible explanation for this phenomenon could be related to the concept of dark energy, the mysterious force driving the accelerated expansion of the universe. Dark energy is thought to constitute about 70% of the universe's total energy content, yet its nature remains one of the biggest unsolved mysteries in cosmology. The new image raises the possibility that dark energy might be behaving differently in certain regions of the universe, possibly resulting in vast voids where the force of expansion is much stronger. This could lead to areas of space where matter is effectively pushed away, resulting in the kind of emptiness we observe in the JWST image. Alternatively, the image might be revealing the presence of new, exotic forms of matter or energy that do not interact with light in the same way as ordinary matter. Could these be previously unknown forms of dark matter, or entirely new particles or forces that have yet to be incorporated into our models? If such matter exists, it could provide the key to comprehending not just the structure of the universe, but also the fundamental nature of reality itself. The potential existence of new forms of matter or energy brings us to another fascinating possibility: the idea that the structures observed in the image could be related to higher dimensions or alternative universes. Theoretical physicists have long posited the existence of dimensions beyond the familiar three of space and one of time, as suggested in theories like string theory. In these frameworks, extra dimensions are often compactified, meaning they are folded in ways that make them invisible to us. But under certain circumstances, these dimensions could influence the behavior of the universe's matter and energy, leading to phenomena that are difficult to explain with our current understanding. As researchers continue to investigate the implications of the JWST's latest discoveries, the quest for answers could lead to groundbreaking advancements in our comprehension of the cosmos and its many mysteries. Let me know your opinion in the comments box. If you liked the video, press the like button and subscribe to the channel so you don't miss our upcoming content. As we stand on the threshold of a new era in observational astronomy, the revelations from the JWST are not only reshaping our cosmic maps but also challenging the philosophical frameworks through which we interpret our place in the universe. The more we learn, the more we realize how little we truly understand. This vast, almost unnerving emptiness brings into question the idea of a uniform universe. Could it be that what we perceive as voids are not merely absences of matter, but rather indicators of deeper, hidden structures or dynamics beyond our current detection capabilities? Some researchers are even exploring whether these voids might act as conduits or gateways to phenomena outside the bounds of standard physics, perhaps linked to quantum fluctuations on a massive scale, or ripples from epochs of the early universe that we have yet to decode. Others propose that the JWST might be revealing evidence of cosmic anisotropy, where the universe is not the same in every direction. This idea goes against the long-standing assumption of cosmological isotropy, the belief that, on large scales, the universe looks the same everywhere. If anisotropies are indeed real, they could suggest that the fundamental laws of physics might vary subtly across different regions of space. The implications of this are staggering. Such findings could not only force a rewrite of the standard model of cosmology but also affect our assumptions in quantum mechanics, general relativity, and even the possibility of multiverse theories. In this sense, the JWST is not just a telescope, it is a time machine, a reality probe, and potentially, the most transformative scientific instrument of our generation. With each image it sends back, we're not merely observing distant galaxies or empty space. We are, in a sense, looking inward, at our own assumptions, our scientific limitations, and our eternal drive to seek meaning in the cosmos. As the data continues to pour in and more mysteries are uncovered, one thing is certain: the universe is far stranger and more magnificent than we ever imagined. And we are only just beginning to glimpse its true nature. Stay tuned, stay curious, and never stop asking questions.